I'm Kirk Harnack. On This Week in Radio Tech, it's a War Stories episode. Great radio engineering stories from the trenches. Chris Tarr is here, and our guest Dana Puopolo joins us on This Week in Radio Tech next.
Netcasts you love.
From people you trust.
This is TWiRT.
Bandwidth for This Week in Radio Tech is brought to you by CacheFly at CACHEFLY.com.
This is This Week in Radio Tech, episode 120, recorded March 14th, 2012. Can you repair these tubes? This Week in Radio Tech is brought to you by Omnia Audio and the hugely popular Omnia One processor. Get your free 5-band upgrade today at omniaaudio.com. Hi there, it's time for This Week in Radio Tech. I'm Kirk Harnack, your host, and so glad that you are with us. Thank you for joining us. It's our 120th show, and it turns out it's our 100th show on the TWiRT network. The first 20 shows that we did after Leo, in a personal luncheon with Leo said, Kirk, I think you can do this thing. I think you should go for it. Well, that's all I needed. Leo Laporte says he thinks it's a good idea. Sometimes is. So we started out this little show as an audio-only podcast back 120 episodes ago, a little over 2 years ago. And here we are up to episode 120, with 100 of them having been done video on the TWiRT network. So thank you very much to Leo and also to Burke McQuinn and Lisa and to Eileen Rivera and others who have helped to prod this show along and make it possible. And also a big howdy do and thank you to one of my co-hosts, the only regular that's with me tonight, and that is Chris Tarr from Mukwonago, Wisconsin. Hey, Chris, how are you?
I'm doing well. Glad to be here. I had to take a couple of weeks off there. I was a little sick with my voice actually was gone with bronchitis last week and the week before. So finally started to come back. So I'm glad to be here. I kind of missed being around. So I'm glad to be back. I'm the Director of Engineering for Intercom Stations in Madison and Milwaukee, Wisconsin, and also run the website broadcastengineering.info and a whole bunch of other things.
All right. I have to write that down, broadcastengineering.info. All right. I want to remind people about that at the end of the show, too. Be sure we do that. So, Chris Tarr, thanks for being with us. You've been a regular co-host since the very beginning, right? Since the first episode?
Yeah, in fact, I remember the phone call that I got from you before the show started, and you were looking for co-hosts. And just out of the blue, I had talked to you for a while. You say, hey, Chris, I'm looking at this new show. Are you familiar with TWiRT? And I said, absolutely. Who doesn't know about that? And you said, yeah, I'm putting together a show, and I think you might be a good candidate for a co-host. And after I thought maybe you were crazy, I went, heck, anything like that, I'm down for that. So the rest is pretty much history,
Well, Chris, in all seriousness, I remember you being an animated character, and the day that you and I first met years ago was on September 11th of 2001. I mean, the famous day. Yeah. I was working for Telos, which I still do. That's my employer. And I was specifically working with the Omnia division. I was showing people Omnia processors. And I was in Chicago that week. And that morning, that fateful morning when the planes were rammed into the World Trade Center and the other places too, I think after I was in the hotel room, watched it all, got over the shock about 11 o'clock, 11:30. I thought, well, I guess I'll just see what I can make of today. And so somehow my phone worked, and I called you up, Chris, Kirk, how you doing? I said, wow, lots going on. And I said,
I remember it was actually pretty interesting. We had I think I had a late afternoon lunch. And it was, obviously pretty somber, and we're talking about, we didn't talk a lot of shop that day. I think we were kind of talking about the current events and everything. But yeah, I remember that very clearly.
Let's make unless you had if we got room for it, let's make that a war story, because you did a lot of engineering that morning, and I'd like to tell the story about that if we haven't already, or even if we have, it's probably worth retelling. But right now, I'm leaving this guy out. I don't mean to at all. Our guest on this show is a guy that's full of war stories himself. It is engineer, longtime engineer, and just this guy knows everything about broadcasting, knows so many people. It's Dana Puopolo, who is a return guest. Hi, Dana. How are you?
Hi, how you doing, Kirk and Chris? I'm doing fine here. Greetings from Philadelphia, where it's beautiful tonight.
Well, Dana, you people know you from, I guess, all over the country. You have held responsible engineering positions in a number of different cities. And actually, yes. I knew you before this, but I was looking for some interesting guests, and I get a regular newsletter from somebody who we both know, Jerry, I hope I say his name right, Jerry Del Cagliano. Is that how you say his name?
Yes. That's correct.
And Jerry is one heck of a writer and knows so much about the broadcast industry. He's a real insider, and it takes a lot of guesses, I think, at what's going on, but oftentimes he's right, way more often than not. And so I asked Jerry, who do you think would make a good guest for my show? And he said, my friend Dana Puopolo. I said, I know Dana. I'll give him a call right now. So
yeah, I used to write for Jerry. Jerry had a magazine, maybe a quarter century ago called Radio Only. And I wrote his tech column every month. It was an interesting time. It stopped when my first daughter was born, and she's now 28 years old. So that's how long ago I stopped writing for Jerry.
You mean he was doing radio only 28 years ago?
He was doing radio only. He owned a daily fax thing called Inside Radio.
Oh yeah,
he owned a magazine called Radio Only. And what happened is somehow he got into an argument with Clear Channel, and they sued him, and he sued them, and they settled, and he was out of radio for a number of years. That's when he went to work at USC as a professor. Well, now he's back, and he's doing his seminars, and he's doing his little pay internet thing. And Jerry has it together. Jerry is a very smart man. Jerry definitely has the instincts, as we would say. And ironically, I found out much later on, he's from Philadelphia. So there's quite a few people here that I know that know him from when he was a program director here. So it was almost like he was surprised to find out I had wound up here at WURD in Philadelphia. Because it's like, look this guy up and look this guy up, and they all know Jerry. It's pretty amazing.
What's the name of Jerry's? Inside Music Media. That's it.
Inside Music Media. That's correct. Yes.
Yeah. If you want to know Jerry's take on the inside workings of radio, and I must say, Jerry can be cynical,
yes,
but he's very insightful, and he connects a lot of dots. Sometimes the dots probably don't need to get connected, but he's always looking, and he's often right. It's InsideMusicMedia.com is his website, and you can subscribe. It's pay, but you can subscribe to his daily email. Where, man, and I'll tell you, Jerry is just a heck of a good writer. He
Jerry's a great writer.
He writes teases in such a way that you oh man, I got to find out what he's talking about.
He does a seminar once a year too on new media, which is well attended, and actually, my general manager has gone the past 2 years. He holds it in Phoenix, where he lives now. And I had her go last year, and she got so much good information from it that she went again this year. So her and Jerry have become pretty tight in terms of, their relationships. And she gets a lot out of his stuff. She gets, of course, as a person who goes to the seminar, she gets, to have the daily, I don't know, I wouldn't call it a podcast, more like the daily journal that he writes.
Yeah.
She gets that every day, and sometimes she shares it with me, and sometimes she doesn't. But Jerry, I agree, Jerry's a good man. And, of course, you and I have had a relationship now for quite a while, through Telos and everything, which, one of the better broadcasting companies out there, or equipment companies, I should say. And it's been fun. I mean, radio's been fun. I mean, I'm sure we all have a bunch of war stories. I've got some pretty funny ones and a couple of pretty sad ones, too. I won't go into the sad ones tonight, but the funny ones we can share.
We're gonna jump into those here in just a minute. I want to remind our viewers and listeners, hey, thanks for being with us. The chat room is alive and well. If you're listening live or watching live, you're always welcome to jump in at irc.twit.tv. And you don't have to be a super geek to make that work. You just go to the link, and there's a web page there that shows you what's going on in the chat room. Our show is brought to you by, this episode brought to you by Omnia Audio. And we're going to talk about the Omnia 1 during the commercial break. I'll tell you some interesting new news about the Omnia 1, so stay tuned for that. All right, we're going to jump right into our war stories. And I want to, if we can, Chris, let's go right back into this thing about September 11th, because this was a really interesting day. We all remember where we were and our emotions on that day. And of course, broadcasters were all shifting gears and trying to get news on, wall-to-wall news. And I was in Chicago, of course, which, stations there are very capable of going wall-to-wall news pretty quickly. You, as I recall, Chris, were working for a medium-sized group of stations. What town was that? Was that in Joliet, or where was that?
I was in Joliet. The company is Next Media. They still own the stations, and they had a ring of 12 radio stations in suburban Chicago that kind of formed a ring around Chicago. And as you mentioned, the Chicago stations obviously were fully staffed, and they were all set to go, and we were able to go live wall to wall. Obviously, with smaller stations, that wasn't necessarily the case. We weren't fully staffed. And so we kind of made the decision early on when I got in the morning that we're going to try to consolidate our resources. And the way we're going to do that is we decided we were going to have one main studio with one set of reporters that was going to simulcast on all of the stations. And then we would take the announcers and reporters and the resources from the other stations, and they would go out in the field and do their reporting and do the research and kind of present it to the anchors. Mm-hmm. Well, the job was getting those 12 stations linked together, which was not a real easy undertaking, especially when you have zero notice. I literally had about a half an hour notice that we're going to do this, and I had to put something together. So, the easiest thing to do is you look at, okay, who has what? And at that time, fortunately in Joliet, we had the rights to the Chicagoland Speedway. So I had already built a part of a network for that with our stations to simulcast the races. So I kind of had some infrastructure there to begin with. So we decided that Joliet was going to be the hub because that's where I originated some network programming from. So from there, we kind of linked ISDNs and kind of formed this chain with the 12 stations. But, we had some interesting things happen. For example, I ran out of feeds because obviously I had a couple of Zephyrs, but I could only feed one station from each channel of the Zephyr. So we started to run out, and I actually had no more feeds. So what I ended up doing was I had another studio where I had an ISDN line set up through another Zephyr, hooked up an FM tuner to one of our FM stations in the market, fed that into the Zephyr, and then fed that to one of the other stations. So, within about a half an hour or so, we had everybody dialed up, and we got all the news on the air. But then it was a matter of, okay, now we kind of had to backhaul and be able to put these other stations on the Joliet station with live reports and things like that. So then we set up a whole bunch of Comrex, probably back then it was a hotline, set up a network of Comrex hotlines to get feeds back. So we essentially created this web network of 12 radio stations in the matter of a half an hour to get the information on the air.
Wow. Yeah, it seems like I called you and you said, yeah, I think I'm getting this stuff just about wrapped up. Come on down, let's have lunch. And it was a late lunch, so I drove on down to Joliet and met you somewhere. Ended up eating at a Logan Steakhouse, and you spent a few minutes describing to me what you'd been doing all morning, just like you did just now with all these Zephyrs and feeds and hotlines going from different stations.
Oh, we literally had wires and lines running down hallways. We had studios repurposed. It was a pretty big undertaking, and in fact, I probably time has kind of worn out the memories a little bit. But I mean, there were things like trying to get phone calls on the air, using our telesystem to intertwine with the other stations to take calls from listeners all over the suburbs. So I mean, there are all these many things we had to do. And, oh, by the way, in 30 minutes. And we actually broadcasted around the clock for probably 3 or 4 days on that network and really had no issues with it. But it was kind of a testament to radio and to the people in radio that, can still pull things like that off. I mean, it was a huge undertaking, something we never thought we'd have to do. I mean, who would have thought back then that we'd have an event of this magnitude that would require getting out information that way? I mean, it never occurred to us. And of course, after that, most radio stations, including us, now have comprehensive plans on what to do in those situations.
Actually, I want to return to that exact question. That's what I was going to ask you next, but I want to bring Dana in. Dana, were you engineering for a broadcaster at that time on 9/11?
I was director of engineering for Clear Channel in Tucson, Arizona. Now, I was asleep when all this happened, remember, because Arizona stays on on Standard Time, okay, which means that the planes actually hit somewhere around 6:30 in the morning in Tucson time. Yeah. So we were 3 hours behind. And I received a phone call from one of the board operators that said the country station program director would like to join with our AM, which was News Talk there. And I said, why? And he said, you haven't heard, have you? I just woke you up. I said, yeah, the alarm clock was due to go off in about 10 minutes. Yeah. And he said, a plane has hit the Trade Center and the Pentagon. And, like, that will wake you up, like, immediately, a jolt. The first thing you think is, you're wide awake, terrorism. So they wanted to immediately join. So what I actually had them do was it was a similar kind of lash up. But what we did was we had the LP1 and LP2 stations for Tucson in our building. We had a cluster of 5 radio stations, 2 AMs and 3 FMs. So what we did was we actually simulcast off the EAS receiver for the AM on all the stations. Well, it didn't sound too bad on the other AM. Didn't sound too good on the 3 FMs. Right. Because we were, in essence, broadcasting an AM station off the air. But it got them on the air, immediately. Because I just said, bring this up on your boards. They brought it up. They're simulcasting. And upon that point, I got in the car, threw my clothes on, got in the car, and started driving in. And I got maybe 2/3 of the way in, listening to the reports, and that was when the second tower fell. Oh, right on the air. And I mean, my stomach. I mean, it made me nauseous just listening to the description on the radio. And we got in, and we lashed up a connection so we could put the AM studio, on with full quality. And we did. We also ran it for about 2 days. Of course, nowadays, one of the first things we did was we simply added the AM station as one of the sources on our air switcher for each radio station. So, because you can switch between the air studio, the production studio, and now you can switch to the AM station. Right. And it was a terrible day. I remember it was a terrible day. And what's interesting about it is my mother-in-law and father-in-law had actually stayed with us for about 2 months, and they moved back to their apartment. They flew back on September 10th. Now, they live in Secaucus, New Jersey, right across from the Hudson. Yeah. So they actually could see the smoke, from their balcony. I mean, it was it was very, 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 very sad for them. I mean, they kind of wish they'd stayed with us for, a couple extra days.
I'm sure they had a longing to be back with you after that had happened. Everyone, or so many people, had a longing to be with loved ones on that date. And all I had was Chris Tarr.
Well, what's interesting about this that I found out much later on was a friend of mine is the head engineer on building the new Freedom Tower.
Yeah, really?
Okay. Yes. I went to college with him. He's a power systems engineer, and he was in the building when this happened on 9/11. They had actually, if you recall, what had happened was the World Trade Center had actually been leased by the Port Authority to another company, a private leasing company. So they owned the rights to lease all the land, all the office space, I should say, and all the buildings in. Now, there wasn't just 2 trade towers. There were 4 or 5 other smaller buildings there that are still there that are part of the center. And he had been given the choice of staying with them or going and continuing to work for the Port Authority of New York and New Jersey and become deputy director of airports. And he took the airport job. But he was there. He agreed to stay on for 8 weeks to train his replacement. And him and his replacement were in the building when this happened. They were in the North Tower when the South Tower fell. And they only got out because they got an axe and they managed to chop their way through a sheetrock wall and then escape through a Borders bookstore that was in the mezzanine of that building. It was very interesting. There's actually, if you go online and search, his name is Alan Reese. And if you go and search for his name, he's actually got a journal that he kept that's posted online through Northeastern University that shows all this. And he managed to get out. He lost over 20 friends, I understand, close friends that worked with him. He was very lucky. Him and one other man managed to get out. The guy he was training managed to get out, like I said, by chopping their way through a wall with a cinder block, cinder block wall with an axe, a fire axe.
Yeah.
And they escaped. And they kept running. He actually wound up sleeping on the floor of a Port Authority building in New Jersey. They managed to make it out through the tunnel. The tunnels, of course, were all shut down, and the bridges were shut down. Yeah. But, of course, he had a Port Authority, he had the credentials to get through. And it took him 4 days to get home. And what was interesting is he told me when he got home, and it's in there, he reached into his coat pocket, and he realized that in the coat pocket was the huge key ring with all the keys for the trade towers that he had. And he threw them down the stairs. He said, I won't be needing these anymore. And he threw them down the stairs. And his son, who was at the time 9 years old, retrieved them. And I don't know whether he does it to this day, but Alan said he used to sleep with those under his pillow. But it's an interesting, if you people can go and do a Google search for this, and it's a very interesting account, of one man, how he survived this, because he very easily could have died there, just like a lot of his friends did.
Absolutely.
But I think 9/11 affected every one of us a little differently. And I think the broadcasters there, I lost a friend who was an engineer for Channel 2 there, Bob Patterson. And I think most of the people, at least from the East, knew somebody that worked there that died there. But, it also kind of showed how, how we can get together. We can sort of work together to get things done, to get everything done. And if you go to New York now, of course, the new buildings, almost stopped off. It's got 8 or 10 floors to go till it hits the 105th floor. And then there's, of course, the spire that's going on top, which will be a broadcast antenna.
I was going to ask if they were going to put antennas on that, and they are, huh? Going to be a big project.
There's a 460-foot, I believe, a spire that is made of a dielectric material, and you can put antennas inside it. And in essence, is a giant radome.
Yeah, yeah. Wow.
And they have tested it. They actually brought it to a sample of it to dielectric, and they didn't do a full size test, but they have tested it, and they found it to be RF transparent as far as I can tell. And it's going up on top of the building, and it will have inside it, anybody who pretty much wants to have an antenna there can have one. And, of course, it will top off at 1,776 feet. So it'll be by far the tallest structure in Manhattan. Now, whether people use it is quite another matter, simply because, with digital television, things have changed. The paradigm has changed. It's either there perfectly or it isn't. It's not like you have ghosting or you have a weak signal or snow. You either have a perfect signal or no signal. So, and people are, I think, at this point are pretty much used to what they have, with everything coming off of Empire. So we don't know.
Yeah.
We'll see what happens. We'll see if anybody takes them up on it. All the FMs have pretty much moved back to Empire. And, of course, they have 4 times square for a backup. So, I think they're set. But that's a war story. I guess that's kind of a sad one we started out with. Now, I have a funnier one if you'd like to hear it.
Tell you what, I want to wrap up a question I had for Chris Tarr, and Dana, you might want to comment on it too, and then we'll go to the funny one, which we could use.
Fair.
Chris, you mentioned at the end of your last comment about what happened on 9/11 for you, And I'm guessing that a lot of radio stations, a lot of clusters of stations that did not previously have easy one button or a couple of patch cord capability to simulcast on all the transmitters that they might have. After 9/11, they built that in. They made that happen. I know that my little stations in Mississippi, we did that. We made it easy to push one or two buttons, and bam, we could have one studio transmitting to everywhere. Of course, if you've got routing switchers, if you're a bigger station that has that kind of thing, probably no big deal to get that done. But I engineered for a lot of small stations. We never had routing switchers, at least none that would cover the whole facility. They might do a little job or two here or there. So one thing that came out of 9/11 from a broadcast engineering point of view is the ability to easily simulcast all the stations. Did you find that to be true, Chris?
Absolutely, absolutely. And not only that, but instructions and kind of an emergency plan. We benefited at Intercom. We benefited with Katrina because our station was WWL, and obviously that was on through Katrina, and that really made us hypersensitive to that as well. So I think not only was there quick ways to get stations simulcasted, but also kind of a plan of attack when these things happen. How do you deal with it? How do you put things not only from the engineering standpoint, but also from the staffing standpoint? Who do you call? What do you do? So I think in a lot of ways it was a horrible tragedy and a horrible thing to have happened. The positive side for the broadcasting field is I think it made us all really take a hard look at how we had things set up and come up with a better way to do it.
All right. And Dana, at your stations in Tucson, did you guys make any engineering or policy changes after that day?
We did. Like I said, we had studio switchers for all the stations, where we could take any studio and basically run it into the. We could take the FM studio, we could put that on the air. We could put the FM production studio on the air, or we could bypass the studios completely and play out from the audio workstation. So if they were running voice tracked, they could put that on the air. We just simply added the AM station as another input because we had 8 inputs on the switcher. So we simply added the AM station as another input on all the switchers. So all they had to do was go into the rack room and just select the AM station to do that, and they were simulcasting.
Sure.
So in fact, we actually did a lot of that morning. It was just literally. Since everything, of course, was, bridging inputs, we literally just looped some wire between all the inputs of the switchers, since they were within a rack of each other, and then just connected that across the output of the AM console.
Hey,
and then switched them all on at a time.
I sense a teachable moment coming right here, because you were just talking about some things that as engineers we became familiar with in the analog world. There's still plenty of analog wiring out there. Dana, you said bridging inputs. And as a young engineer, I remember trying to figure out what's the difference between a 600 ohm input and a high impedance input, a bridging input. What does that mean exactly? Why don't you tell us and our audience, what that means? What can you do with a bridging input that you can't do with maybe an older-fashioned 600 ohm input?
Well, of course, in the olden days, everything was transformer inputs and outputs, and to get the proper frequency response, everything had to have a 600 ohm source. You had to come out of a transformer or a pad that had 600 ohms, and you had to go into a 600 ohm load, have everything matched. Mm-hmm. And if you couldn't do that, then you used what was called a matching pad to go between the two that would match the unequal impedances. If you didn't do that, your frequency response and distortion would be all screwed up. Well, now and that's what's called a power distribution model.
And wasn't that because we were using transformer outputs and transformer inputs, and transformers
Correct.
had to be terminated with their characteristic impedance? Otherwise, the frequency response wouldn't be right on that output. So if you had a 600 ohm transformer, you had to terminate that with 600 ohms. Modern circuits, a modern electronically driven op-amp output, maybe it's got a build-out resistor to protect itself, but a modern output doesn't have to be terminated with any given characteristic impedance. It's going to have good frequency response almost no matter what you terminate it with. Yeah,
that's correct. It's going to typically the output impedance, and it actually goes back further to. Actually, I think it goes back to the Bell system that we use 600 ohm things. It went back to the old telephone circuits, even dating radio. I mean, that was just the standard that they used. The modern system of voltage distribution works on the fact that the outputs of a very low impedance, typically 100 ohms or less. Like you said, you can have a couple of 50 ohm build out resistors, but basically you have 100 ohm source impedance, and the loads are usually 10K or higher. So you've got an output that will drive a 600 ohm load or a 1,000 ohm load, and you can put 10 of these 10K loads across it before you even start to affect the quality of it.
Yeah.
So that's what you mean by bridging. Anything that's considered what we call bridging is anything that's 10 times the impedance that the op amp will drive. So
always
if the
like to use the
drive 1,000 ohms.
Yeah.
You can put 10,000 ohm ones bridges across it.
In the chat room, it was asked what was special about 600 ohms, and I'll take a crack at this, and you tell me if it's different. Why did the phone companies have characteristic impedance of 600 ohms on all their circuits? And my answer would be, well, because that was a convenient size and winding to make an audio transformer. And so on your telephone set, there'd be a transformer, actually kind of a simple hybrid on its input. And at the phone company, I guess there were transformers there or hybrid outputs there at the phone company. And 600 ohms was it's a convenient size, and it seemed to work, and it was a good compromise between voltage and current to get an audio signal to go a long ways over a pair of unshielded wires that were balanced and have reasonable audio show up at the other end. If they had built the whole system based on 5,000 ohms, then you'd have a lot more problems with distributed capacitance, for example, along the wires. But if it had been 20 ohms, then you would have had to push a whole lot more current through the system to make it work well, and then you would have a lot more I squared R losses, if my math is correct.
That's correct. And also remember, microphones have always been 150 ohms usually. I don't know where that came from, but the 600 ohm came from, it's a standard that they came up with. If you remember, everything's in dB or decibels. Well, the bell, actually, they dropped one of the L's, but the bell was originally DECIBELL, as in the bell system.
Yeah.
And what they did was they standardized at 0 dB is 1 millivolt across 600 ohm across a 600 ohm load. So that's what 1 decibel is in terms of power. And of course, you can have +4, +8, whatever, +10, and everything seemed to have a different standard at the time. But the transmitters of the 60s and 50s required +10 for 100% modulation. The consoles would only put out +8, so you had a mismatch right off the bat. Wait a
minute. You mean this is just like going to the store and hot dogs come in package of 10 and the buns come in package of 8?
That's correct.
Same thing.
Yes.
Okay.
Yep.
It's the beauty of standards. There's so many of them.
It was an interesting time, Now, of course, everything's pretty much standardized on what's called the voltage distribution model, where you have the low source impedance and the high load impedance, and you can pretty much throw anything across anything, and it all works just fine. So I mean that's an improvement. It's a big improvement. I mean, transformers are hardly ever used now. They're basically only used, if you've got an outside telephone line. The reason is because you simply don't want to take an op amp and present it to the outside world. Op amps and lightning and voltage surges don't seem to get along too well.
Right.
But otherwise, I mean, I know very few boards that even use transformers anymore, except in the power supply, of course.
Hey, Chris Tarr, how many decibels does your transformer have?
220, 221, whatever it takes.
Whatever it takes, that's right. Actually, it's good to know some of this lore, some of this, these older standards, because let's say, for example, you need to go do a remote broadcast, but it's not so far away that you can't run just a long wire. I'll give you an example. Some years ago in Memphis, some years ago in Memphis, Tennessee, we wanted to do a live broadcast from the rooftop of our downtown studio building to give a little updates on the fireworks display on the 4th of July. And so the program director asked me, hey, could we get a mic run up to the roof? And I said, well, we could, but we don't have one of those little 2-watt Marty systems, and the Marty that we have won't reach to the transmitter site from right here, I don't think, and blah, blah, blah. And I thought, wait a minute. I got 1,000 feet of Belden wire in my office. I wonder if I could just use that. Well, I didn't need 1,000 feet. I only needed 250 feet to go up the stairwell, or less than that probably. But I didn't want to cut my wire either. So what I ended up doing was I took this roll of Belden, I think it was either 8451 or 9451, just twisted, stranded, shielded pair of wire. And I ended up I could access both ends of the wire. One of them was on the inside of the hub, so I stripped that and put an XLR connector, probably a male XLR connector there. A female there, and I put a male on the other. Anyway, I ran this up the stairwell to the roof of the building. Mm-hmm. And it turned out that we had a dynamic mic. It was probably an Electro Voice 635, the one that either can work as a hammer or a microphone, whichever you need. And plugged that in, and at the other end plugged the other end of this into an audio processor that I know had a transformer input on it. So we were all good and balanced. The mic has a transformer in it. The audio processor, the mic preamp, has a transformer in the front of it. We had perfectly clean audio with 1,000 feet of wire and no noticeable loss of high frequencies over that 1,000 feet. Why? Because we had a 150 ohm a path going on there, terminated at each end, and the audio just was happy as could be with that, even though it was 1,000 feet of wire. And that's the kind of that's gonna work well. That's how phone lines work, basically.
And that's correct. In fact, one of the simple things that's done is there's something called a coil equalization that's used with a lot of the phone companies, and all they do is they take a telephone coil and set it up for 600 to 150. So they're actually driving the line with 150 ohms, and you can actually get flat frequency response up to about 15 kilohertz. And my daughter's joining us here, as you can see. Flat frequency response up to about 15 kilohertz on about 1.5 miles of 24 gauge wire that way. It's one of the simplest ways to equalize through a coil equalization technique like that.
That's one of the ways that engineers have used if they have to get something on the air. You can on the show we've talked about these 111C repeat coils. These are these big. They're bigger than a coffee cup, right?
Yes.
They're made by Western Electric. They're valuable. Now, in this day of more and more digital stuff, maybe they're less valuable, but they're also harder to come by. But this thing can be wired for either 150 ohms or 600 ohms of impedance on each side, the primary and the secondary side. So what people tended to do, if you need to run good quality audio over some distance, wire the side facing the broadcast equipment for 600 ohms and wire the side for the long piece of wire for 150 ohms, and do this at both ends of the run. So you have a transformer at one end and a transformer at the other end. And again, the long wire is seeing 150 ohms, and then your broadcast gear is 600 ohms. And this works beautifully. It's quiet. Its frequency response is just fine. And, no fancy electronic circuits involved, and you don't have to pay anybody if you can run the wire yourself. You don't have to pay anybody to equalize it for you. It's not necessary.
Yeah, it works beautiful. Like we used to do that on college campuses. It worked beautifully on college campuses. It was the way to go. 111C coils, try and find them on eBay. You'll probably find they sell for around $100 a piece now. They're quite valuable. Yeah. Another trick with those we used to do is like we would replace the output transformers in a lot of the solid state boards with those, like the the Autogram boards and the Harris boards and the like, with those repeat coils, and it would make them sound quite a bit better.
I bet it would. Those things were pretty flat up to about 53 kilohertz, as I recall, so they had nice response. Hey, guys, we're going to take a quick break right now and hear from our sponsor. I want to remind you that you are listening or watching This Week in Radio Tech. It is our 120th episode, and it's our 100th episode here on the TWiRT network. And so thanks very much to the leadership of Leo Laporte and his crew, and also Burke McQuinn, who's been with us for most of these shows, producing them back in Petaluma, California. So thanks very much. If you want to get our show the easiest way possible, go to the website, go to the TWiRT.tv website, and go to twit.tv/TWiRT. twit.tv/TWiRT, and you can watch the show there. You can download it, or the easy thing is you can subscribe to it. You can subscribe to it in iTunes or any of several RSS feeds and have it show up in your either your inbox or your iTunes or whatever your player is. Just have it show up there automatically every week or so. And then you can enjoy it and at your leisure if you can't catch us exactly live. All right. Thanks to Omnia Audio for sponsoring this episode of This Week in Radio Tech. I do work for the company, so I kind of have the inside track on what's going on there. I want to mention to you the Omnia One audio processor. This is a very versatile processor because we designed it with several different software loads that you can put into it. Exactly the same hardware, whether you're using this for AM, for FM, for what we call multicasting, and that's what the TWiRT network uses. They use the multicast software, which is specially designed to process audio to feed a bit rate reduction codec like MP2 or MP3 or AAC or aptX. Anything that's going to cut down on the bits, this processor will do it properly for you. And there's also a Studio Pro version of the software, too, that just does good studio-style processing, doesn't do any pre-emphasis or de-emphasis. It just does a good job of multi-band compression and multi-band limiting and no clipping. Well, here's the exciting news. The thing that just we were high-fiving around the Telos offices a couple weeks ago. Folks around the world have now purchased over 7,000 of these Omnia One processors. They are everywhere. I mean, at college stations, at community radio stations, and big market stations where they can't afford to buy maybe an Omnia 11 or an Omnia 9 or the high-end Orban processors. They're putting in Omnia Ones. The FM version of the Omnia One now is a 5-band architecture instead of the original 4-band architecture. I want to remind you that if you've got an Omnia One FM processor and it's the original 4-band architecture, you've got a free upgrade coming. You can just go to the support area and the downloads area of the OmniaAudio.com website and download the new 5-band software for your Omnia One processor. And that's just for the for the FM version of the Omnia One. It's one rack unit tall. You can access it with a web GUI and play with it that way, which means you can access it from home or from the office, from a good listening point, and play with the processing that way. It's very cool. Check it out on the web, if you would, at omniaaudio.com/one. That's ONE. You can also, by the way, sign up to get our catalog there at the Omnia website. And we'll send you one. And then you can download it in a PDF, and you can put it on your iPad and take it with you wherever you go. All right. Let's move on. We are episode number 120, which means it's a War Stories episode. And I'm joined by Chris Tarr, the chief engineer for Entercom in Milwaukee. There he is. And also Dana Puopolo is our guest this week. Dana's been with us once before, and he's got plenty of war stories to tell. Let's see. Dana, you had a happy story to tell us, and I want you to pause that for just a second.
Sure.
Chris Tarr has a tour that he is going to take us on, a magical mystery tour, through a transmitter site. I hope Burke has that just about ready to go. Chris, is there any lead up you need to do to this tour as we watch it or get ready to watch
actually,
it?
I went up today to check on the air filters and get the building kind of opened up for the warm weather. I thought it'd be a good opportunity to take a couple of minutes and just do a quick tour. What got me thinking about it was I just recently, in the past 2 weeks, got all of my stations, the 3 in Milwaukee and 3 in Madison, through the alternative inspection program. And so I had to actually go and take an inspector through all this stuff. I went, while I'm here, with the age of iPhone cameras and things, I could probably just videotape something quick while I'm here for TWiRT. So that's what I did. I did a quick tour of one of my transmitter sites, and this is what we have for you. Hello there. Welcome to my transmitter site. I'll be taking you on a little tour here of what we've got. We'll kind of pan around here. We're standing pretty much by the front door. We've got some racks over here. We've got HD transmitter, analog transmitter. We've got cabinet, workbench. It is pretty dusty in here. It's about time for me to do my spring cleaning. But let's take a quick tour of all the toys we've got here. At this site, I have two paths. I have a main audio path and a backup audio path. What you see at the top is a Mosley digital decoder for an analog STL. And what that is that's my backup path. That carries 4 channels of audio. And the reason I have this set up this way is we have a site not too far from here that's our auxiliary site for 2 of my FMs. And it happens to be less than a degree difference in receive area from where we're at now. So I can use one transmitter to send both to both sites. So I actually have 2 of my FMs here. This is the FM that's at this site, and this is the audio from the other FM. And it actually goes to our auxiliary site as well. At any rate, so we just only actually take the feed off of the one channel. But that's our backup feed. Next is the Tunwall switch, custom made by Steve Tunwall. And this is to switch around our HD and analog transmitters. I'll show you more on that in a minute. HD radio tuner, the Interplex system. Now this is our main studio to transmitter link. And what this is a T1, and you can take the time slots from a T1, divide it up, and use it for different things. So right now I've got analog audio coming up through here. Also some bandwidth from our WAN for carrying data up, as well as HD programming, and our remote control as well. Below that, the Automat Aztec RDS encoder. Below that, there's the analog receiver for the STL. The output of that actually feeds the digital decoder. So that's sitting right there. Rack number 2, up on top, our main audio processor. That's an Optimon 8500. Below that is our mod monitor. As you can see, we're doing the speed limit there, 100%. Our Burke remote control. Some audio switching. Watt meter for our dummy load. And then below that, this box down here, what that does is that switches between shore power and our UPS. And I came about that is one time we had a UPS that powers our remote control and our audio and all that kind of stuff. And it died spectacularly to where it cut off power to all those devices and we went silent. So what this box does is it monitors the power, and if for some reason there's no power coming from the UPS, it switches over to shore power to prevent that from happening again. All right, next. We've got the NE-IBOC, which is the non-tel exporter for HD. As you can see, it's running along there, runs on Linux. Below that is the digital power meter. This is the watt meter for the power coming out of the combiner, combined digital and analog. The NE-aux is just a delay box. We only use it for the GPS function. Another UPS, an audio switcher, and Cat5 switching. Below that is a PC. What that PC does is that PC rotates on, I believe we're using Winamp to rotate just songs and IDs. And if for some reason the studio goes dead or both transmitter links go down, we can turn that on with this switch right there, and that puts that PC on the air. We have programming running from here. All right, this is our HD transmitter. Right now it's running in digital mode at about 3 kilowatts. Keep in mind, with the injector process, 90% of that goes out as heat. So it's really 300 watts coming out of the antenna. That's an Untitled V10. Over here, the analog transmitter. The feed to the tower after the injection is 21.5 kilowatts. Into the injector, transmitter power output is 23 kilowatts. Got that there. What's interesting about the non-tel is it is mode agile. So we can actually run this as our backup transmitter in analog at 10 kilowatts. Oh. However, in order to do that, we have to bypass the injector. If you know anything about high-level combining, you know that as part of the injection process with the HD transmitter, 90% of the power gets wasted as heat. Obviously, you don't want to do that if you're running on a backup analog. So we have the switcher set up to allow us to switch the V10 transmitter around the injector and bypass it and connect it directly to the antenna above, which then gives us a full 10 kilowatts out to the antenna in backup mode, which is nice. So all of that is actually suspended from the ceiling. You can see it took us almost a very hot summer to put all this together and get the plumbing put in. But you can see the result works pretty well. We've got that, and then all we need to do is with the remote control, we hit one button, and the transmitter switches modes and power, the antenna switches switch, and boom, you're ready to go on as a backup in analog mode. And you can see there the HVAC system we put in, the hood and everything for the exhaust, and same thing over there with the transmitter there. So there you go. In a nutshell, that's it. Outside, I'll let this focus a little bit. You can see you got a whole solar panel field out there. Unfortunately, the one thing they didn't think of when they put those in is ice falling off the tower. So there are a few of those panels that are smashed up. Then right behind us is a little over 1,000-foot tower. We're almost at the 1,000-foot mark with a 4-bay, half-wave spaced antenna system. So there you go. One last look. We'll back out. We'll pan around. And now you've got the nickel tour of one of my transmitter sites.
Chris, that is cool. The chat room is really reacting to that tour. Nice job.
Just for the moment thing, I took that with my iPhone, actually.
Yeah. Well, it worked. It worked fine. Hey, I'm sure I can. I had a couple questions in mind. Oh, yeah. So the Nautel as a backup, you said it's analog only. Can it operate as analog and digital at the same time at a really reduced power level, or is it really one or the other?
Yeah, no, it will do. It does run a hybrid mode. It will run analog and digital, but I believe the maximum power is 6 kilowatts analog with digital. So we'd much rather just go the full 10 kilowatts in analog when we're running in that mode.
Ah, okay. People were asking about the Burke remote control. And Burke is a famous name in broadcast radio engineering for remote control systems. And no, there's no E on the end of it like there is for our esteemed producer back in Petaluma.
Correct. No, Burke, yep. Burke is, yeah, there he is. Burke is kind of a big standard, and that you'll find a lot of those. That particular model is called an ARC 16, and they're very common. You run into them all over the place, and they're workhorses. They work pretty well. You put them in and leave them, and they just go.
You know, I think that tour that you gave us was that may be the first time on this show that we've ever been able to give our viewers a look at the significant RF plumbing that goes on at a site where you have more than one transmitter. Maybe you have more than one antenna. Maybe you have, as you have an analog transmitter and a digital or analog or combined transmitter. So you've got to make way for some options here. Plus, maybe you had a dummy load there too, right?
Sure. Well, we have another site, and I'll try to do a tour of that one. It's much smaller. Same kind of theory, where we have one transmitter that does digital plus an analog backup. But in that scenario, I actually have an auxiliary antenna as well. So that requires 3 coax switches to make all of that work. But in this particular situation where I was doing the tour, we didn't have a lot of space to put all that stuff. So as you saw, we had to actually construct a frame and suspend it from the ceiling. And it was myself and a couple of other engineers that did this over a summer, and believe me, there's no air conditioning in that room. It was hot in there working.
Did you design that? Did you design that switching system yourself? Did you draw it out? Because these switches, they're unusual for folks that are not in broadcast. They have 4 ports on them, and in one mode, 2 of the ports are connected together, and you switch it, and they're connected this way. And so you got to think about, okay, what am I going to do? How many switches do I need to accomplish what I want to do? And to my brain, it's just thoroughly confusing. Now, sure, I've looked at a few systems that were all planned out, and they had the little diagram showing what goes to what. And you can really do a lot of stuff with these, but it may take several switches to get it done. How did you model this in your head to get it where you understood what's happening with these switches?
It's almost, if you look at the front of the switch that Burke had up a minute ago, that's almost exactly the diagram that I drew out to kind of put it in my head. And Steve Tudwell's great. He builds these custom. And so I gave him the specifications and told him what the switches were supposed to do. And then he programmed the controller and built it on his own. So you can kind of see there as he's moving the cursor of the mouse around, the 4 yellow LEDs in the center, those are the ports on the switches. And so all we're doing is we're just routing the RF either in or out of an injector and in or out of the antenna. So, it does take a little bit of, you kind of really have to sit back and think and draw it out a few times. And especially, the station I have with the 3 switches and the backup antenna, that requires a whole lot of pre-planning, because then you have a whole bunch of combinations. But what we wanted to be able to do with this is we wanted to be able to not only bypass the injector, but we wanted to be able to put the HD transmitter or the main transmitter into the dummy load while the other was running. So that's where you really have to get creative, and you go, okay, here are the parts that we have. Here's where we want the RF to go. How do we set up the switches to do it? And it does. It takes a little time to plan it all out. But, fortunately, that's one of those things I think really well in that mode. So it was pretty easy for me to kind of put all the pieces together to make it work. But it is kind of cool to watch. And, and also one thing you don't think about is with Steve, we had to work through them to work all the tallies so that they were right. So we were locking out the appropriate transmitters in the appropriate modes because you don't want to have, obviously, a transmitter into something it shouldn't be going into and being able to be turned on. So there's, Steve Tunwell did a fantastic job with the programming because there's a lot of that has to go on in the controller.
You bring up a good point, is that when these switches are transitioning, you want the transmitters off.
Correct.
Right. So these switches, they have positioning switches, or that tell what position that this big honking switch is in, and there's motors that run this back and forth. But if you're going to push a button to if you're going to push a button to switch something, the very first thing that has to happen is transmitter off, right? And then the switching takes place. And once everything's checked that, okay, these switches are locked in place where they're supposed to be, then we can turn transmitters back on again. That's some logic to figure out.
And there's even one step further. For example, one of the positions is a dummy load. If the dummy load isn't on, the fan for the dummy load isn't on, you don't want a transmitter transmitting into that because it'll quickly overheat and fail. So you want to have, you want to have the interlock on the fan tied to that as well. So, not only does the switch have to be in the right place, but the fan also has to be on in order for the transmitter connected to it to turn on. So there's a whole lot of logic and tallies that have to go on there to make all of that working. So
I want to hear Dana's take on this. Dana, I'm sure you've worked at transmitter sites with plenty of those big RF switches. And I think they're fascinating. I've rebuilt a couple of these things, and man, you can put a lot of sweat into one of those. What are your comments, Dana? What can you teach us about these big RF switches?
Well, my connections work.
Bad news, Dana. Your mic is just awful. Not sure what it is. Sounds like
Dana,
an analog.
USB mic. Just unplug it and plug it right back in. It'll start working.
If it's USB, unplug it and plug it back in. Yeah.
There you go. Is that any better? It's analog, but we can see
it's much better. Perfect.
There you go. I actually know of one AM station in a major market, a top 5 market, 50 kilowatt AM, that actually hot switches their phaser with a DX50. In other words, I discovered this one day when I saw the pattern change on this station and saw a spark in the phaser.
Yeah, okay.
That you could clearly see through the crack in the cabinet. And, big bright spark that you could actually see through the crack and the air crack in the cabinet. And I was like, whoa. But apparently they never interlocked the stuff. So that'd be that. But yeah, it's just, I enjoy doing that kind of work. I actually had a rigger that is no longer with us who did superb RF plumbing. And the reason that he was able to do it so well was that before he became a rigger, he was actually a plumber. So he knew how to work with that kind of stuff.
Yeah.
It was, he did some beautiful stuff. The stuff I saw from your stuff, Chris, looks pretty good. Looks like you did a really good job there. You should be proud of your installation.
Oh, well, thank you. Yeah, it was, I actually had a good mentor. That was really my first major project doing that kind of work. And there was 3 of us, and we, like I said, it took a good part of a summer to get the HD transmitter in there and wired up and the plumbing done. But what he taught me too was how to kind of that whole assembly, how to plan that out in advance, especially when you have to the switches kind of have to measure out right for the connectors to match out right, and there's a lot of planning that goes into doing something like that. And you're right, it's almost like an art to get the RF set up and the plumbing just the way it needs to be in a situation like that. And oftentimes I see it done. I see it done really quickly and not very well. And a lot of times instead of using hardline, using flexible coax or heliax or something like that. And it's nice to see And I see a lot of sites like that where they do a fantastic job, and it's great to see, something like that. And I'll tell you, the maintenance is very little on it. You keep the site clean, and when it's designed well and put together well, it's you really don't have any problems.
Yep.
Dana,
Yep. Yes, go ahead.
Dana mentioned an interesting word, and that was phaser. And we're going to have a whole show on RF plumbing and AM directionals and phasers. But what Dana was talking about was actually probably a phaser cabinet that contains a lot of tuning parts, capacitors, and coils to divide up an AM transmitter's output power so that it goes to several towers, and the signal going to each tower, the power going out to each tower is at the proper amplitude and the proper phase with relationship to a reference tower. We ought to cover that in a future episode, because there's a whole bunch of plumbing and electronics involved there, a lot of theory and practice too. Hey guys, we're going to run out of time before too long, and I want to make sure we get to Dana's happy story. Dana, you had a war story that had a little happier tone than the 9/11.
I did. I do. As I was a contract engineer in the 80s, and contract engineers at the time made quite a bit of their income from doing audio proofs. The FCC used to require once a year that a radio station would do a proof of performance, basically measure the frequency response and the distortion and the at different modulation levels in the AM noise, and in the case of FM, the FM noise, and all this stuff, and for AM, the harmonics. And what you would have to do is actually plug an audio oscillator into the microphone input of a console, and you'd turn off all the compressors so they were in circuit, but no compression was taking place, and running them as amplifiers, and you would proof these stations. And it was great because, for the typical FM, people would get $400 to $500, and if there was a problem, of course, you could fix it for them too and make some extra money. Well, that's all gone by the wayside. But the story I have involves an AM station. There was an AM station in Massachusetts, a little non-directional kilowatt that was built in the 70s. Not the best built, not the worst built, kind of in the middle, and the station was being sold, and the old owner was a friend of mine, and he called me up and he said, "Dana, I have to have an audio proof done on this to close the sale. The purchase and sale agreement requires an audio proof. Can you go do one for me?" And I said, "Sure, we'll go do it together next week." He goes, "Okay, I bought a whole new set of tubes for the transmitter. We can put those in, we can tune it up, make sure everything's good, and we'll be done." And that's exactly what we did. We went out there, I put all the tubes in the transmitter, retuned the transmitter. He ran the oscillator at the studio. I did all the measurements at the transmitter. Thing flew through the proof. It passed with flying colors, and the station was sold. And I never heard another word from the new owner until one day, maybe about 2.5 to 3 years after the sale, I get a call from the owner, the new owner. Now, I haven't heard a thing from him this whole time. He didn't want any proofs done, didn't want any work done, nothing. And he says, "Dana," he goes, "my station sounds just awful." He says, "You can't pick this thing up 10 miles out of town now. It's all distorted. It's weak. Other stations are bleeding over onto it. It's to the point where, clients are canceling schedules because they can't hear the radio station, at their place of business. Can you help me?" And I said, "Sure." And I drove out. And as I was driving out, sure enough, the station where normally you could get it 30 miles away, you couldn't even tell it was there 30 miles away, or 20 miles, or even 15 miles. Well, sure enough, I get within 10 miles of the station, and I tune it in, and it's all weak and all distorted, and it sounds just terrible. It is one of the worst sounding AMs I've ever heard. No modulation, complete distortion, and it's very obvious what the problem with this station is. The transmitter needs tubes, because I know the last time the tubes were probably put in this thing, because I probably installed them before I did the proof. So I walk into the station, and I stopped at the transmitter on the way, and I looked, because he had left the key, and sure enough, transmitter's putting out about 400 watts. It's modulating to maybe 30 or 40%, and just a total mess. So I go back to the station, and I go into the owner's office, and I say, "It's very obvious what the problem is with your transmitter." I said, "It needs new tubes." And this person looks at me with a complete straight face and says to me, well, you're an engineer. Why can't you fix the old ones?
Why can't you fix the old tubes?
I was ready to get a hammer. I was going to go out there with a hammer and see what I could do.
Now, and I'm guessing, what kind of tubes did this transmitter have? Were they big glass envelope tubes, like 833s or
400As? Yeah, they were
400As. Okay, kilowatt size transmitter. Yeah,
correct.
Yeah. So these have a metal base, but that's just to help kind of hold the pins all together. The tube is 90% glass on the outside.
Correct.
Yeah.
And they will last typically 18 months. You get about 18 months out of them.
So you get out the Windex and you clean up the glass with the Windex, put it back, and there you go. Fix the tube.
But he said and he was totally he was sincere. And I calmly explained to him, you can't do that. I said, the tubes wear out and you have to buy new ones. I said, and that's the reason why your radio station passed the proof when you bought it, because the former owner bought a whole new set of tubes and we installed them and got the transmitter going. And finally, it was an educational moment, because he actually began budgeting every 18 months or every year, actually, a new set of tubes. As I said, you have to do this as part of the cost of doing business. And he actually did. And from that point on, his station sounded fine. But this was one of the more interesting stories I had heard. I'd never heard anything like this before. And he was completely honest. He was not being facetious. He was dead serious when he said this.
Well, I think that's great that you educated him and that he was willing to be educated. And you would liken tubes to a set of tires on your car. You can't rebuild a set of tires. Once they wear out, you buy new tires.
Correct.
Wow. Good story and good teachable moment. I've had owners that didn't want to buy tubes and weren't going to buy tubes until they were actually off the air. It didn't matter how bad they sounded.
Well, This guy was not known for spending money. I mean, years later, his coax blew between the transmitter and the tuning, box at the base of the tower. And he called me up on a Saturday night and said, I'm off the air. What can you do? And we wound up going to Radio Shack right before they closed and buying a 200-foot spool of RG8, a CB coax, and running that out along the ground, hooking it up to the transmitter. And we actually got it close to making power. And, of course, that will run fine at a kilowatt. But I understand he never called me back after that. And I understand that an engineer friend of mine that took over the station after he sold it actually found the coax still in use and still run out in the field behind the transmitter building 5 years later.
Yeah. Wow. Guys, we've burned up an hour chatting about all these things, and there's still a ton of questions in the chat room. I've got a little idea for a little show after the show, but right now it's time that we actually close the show out by giving away the very last Omnia AXE that I was allocated by the folks at Omni. I think we've given away close to 30 of them, and we do this by we have a little contest. If you before the show, this time about 40 minutes before the show start, I tweeted from at K Harnack and also at TWiRT Show on Twitter that Dana Puopolo was going to be our guest and that we're going to do the show coming up pretty soon. Folks retweeted that, and that's how you enter to win. And so, Dana, I need a random number between 1 and 17.
Let's do 11.
11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is a guy that I see every week, but he's never won. So I hope he's going to be glad to win. Good.
Very good.
Our winner, the 11th person on my list here, which I think is actually backwards, to retweet is Bill Meeks. Bill Meeks. You have won a license of Omnia AXE. And we know Bill. I've even met Bill once in person at the Cracker Barrel just down the street from my house. Bill is a graphic designer, and he does fantastic work with some animation and such. So, Bill, congratulations. Maybe now you'll be a broadcaster, Bill. So, Bill Meeks, thanks for retweeting. Appreciate it very, very much. And Bill retweeted to 395 followers. So, hey, whether you've got 3 followers or 400, I appreciate you. All right. Dana Puopolo, thank you very much for taking an hour and a half now out of your evening and being with us. I sure appreciate it very much.
You're very welcome. I'll do it anytime.
Oh, do you know if you're going to be at NAB this year?
I'm going to try to be at NAB. It's one of those things where I have my pass. I'm actually going as a result of if I do go, I'll go as a writer, because as some people know, I actually do quite a few reviews for Barry Michigan's broadcast list. So he's got credentials for me, press credentials, and I have a friend who lives there. So it's going to be a last-minute decision, basically.
All right. Well, good deal. Well, if you're there, I hope we can connect and have a sandwich or something. Hey, Chris Tarr, also, thank you for being with us this evening from Mukwonago, Wisconsin.
Pleasure as always. I won't be at NAB this year. I am, however, it looks like I will be back at Dayton again this year for the Hamvention. So I'm looking forward to that.
What's the date on the Dayton Hamvention?
It's the 20-something of May. I don't know the exact dates. I believe it's 22nd, 23rd, 24th, maybe. But it's at the end of May.
I got to check that out. Okay, because by then by the way, folks, you know, a lot of fanfare when Kirk Harnack actually passed his general amateur license exam at the Brick Twit House in Petaluma.
Yeah,
and so I've been shopping and trying to decide what to buy. I didn't want to buy a used pig in a poke as far as an HF transceiver. So I found a lightly used, almost new ICOM IC7000 HF. And, but I got it for about $500 off the list price. Hope it works. I think it will. And so I've been collecting. Here, let's see. You can see it. I got my Astron linear power supply back here. So that came in today, actually. Just getting it warmed up. It's putting out 14 volts and 0 amps right now. Yeah. Oh, sorry about that. Am I in your way? Yeah. There's the Astron power supply. That's going to be powering the.
Get it together there, Kirk, so we can get on the air and talk to each other.
Yeah. I'm looking forward to getting that tried out. Well, hey, anyway, thanks, Chris. Appreciate it. And maybe I will be able to see you at Dayton Hamvention. Hey, thank you for watching This Week in Radio Tech or listening. Please tell your friends, and we look forward to seeing you again next week. By the way, next week, our guest is scheduled to be Marvin Caesar. Now, you may know that name. He's the guy that owned and ran Aphex, the company that made the original Aural Exciter and the mic preamps that had the big bottom. So Aphex made a lot of cool products, and I guess they still do, but Marvin is no longer at the company. I believe he sold the company, and he's traveling the world. He's going to take an hour out to join us next week on This Week in Radio Tech. Also, thanks to Omni Audio for sponsoring this show. And thanks a lot to Burke back at Petaluma for switching the show and putting up all the lower thirds and generally producing the whole thing. Appreciate you very much. Got to go. See you next week on This Week in Radio Tech. Bye-bye, everybody.